Hello fellow radio amateurs, it's Joe here, ZL1PMY, and on the bench today we've got a Kenwood TS480 Sat, and the owners sent this in saying that the auto antenna tuner has ceased to function. Now the auto antenna tuners are in general pretty reliable. There's not a lot of components in them to go wrong. If they do go wrong, it tends to be burned out relays from high RF voltages. So I thought it would be worthwhile exploring the test procedure and fault finding for this particular fault. And with that in mind, I've taken all the covers off the radio set, and I hope to demonstrate why it isn't the antenna tuner that stopped working but something else. So the test setup here, as always, we've got the 20 amp power supply over there, and the RF test set is connected through a 200 watt dummy load with a minus 10 dB output. So the wattage you see here on the watt meter is actually 1/10, 10 dBs down. So 1 watt showing here would be 10 watts into the dummy load. So that's the test setup. So looking at the radio set, here we see the RF deck. So these are the final pair of FETs, and they're driven by a push-pull pair of FETs on a little sub-module, which is driven by two other FETs which are getting quite small to see. Let's see if I can get some sort of pointer down there. Yeah, I'm in the usual trouble with the camera, but there's a FET there and one there. So those two drive these two, which drive the main pair. And the output of the push-pull pair is combined here and sent through to the filter unit, which is on the underside, and that comes back to the auto tuner, which is this module here. I'm just going to flip the set over now to show you the tuner detector on the other side. So here you see the actual antennas, and they're switched by a relay, but you'll notice two inductors here, and these two inductors actually measure the forward VSWR and the reverse VSWR, voltage standing wave ratio, and the little processor does a sum to give you the actual standing wave ratio based on the difference between those two. The third inductor gives you the phase handle of the forward load, which helps determine the actual tuning steps required to bring it to resonance. This here is the low pass filter board. So the RF generation, which is going towards the transmitter, goes through a band pass filter, then into the driver transistors, which I've shown you, then into the power stage, and finally through the auto tuner, controlled by the measurements made on this board. So with that, I'll show you exactly what's wrong with this radio, which is not the antenna tuner. So stand by. Now, in order to explain how the antenna tuner works, in the early days of auto antenna tuners, it was found that if you put too much power into the antenna tuner, you blow the detector diodes, which are on the forward and reverse voltage detection circuits. And so when you press the tune button, the RF input to the antenna tuner is automatically reduced to around 10 watts, and that's used to tune the antenna to resonance, and then the tuner drops out, signals the main processor that the antenna is tuned, and that will allow the radio set then to produce the 50 or 100 or whatever power output your transmitter is, and in this case it's a 100 watt unit. So when we press the tune button on this particular set, the microprocessor sets CW mode, so you get a continuous wave. You can't use SSB in an antenna tuner. The wave has to be continuous to make the measurements possible. So you press the antenna tune button and the rig will change to CW mode and output 10 watts. In this case the 10 watts is programmable directly from the microprocessor. So in order to do a test, first of all let's have a look at the SWR that's there at the moment. So I'm going to press the PTT, and you can see the SWR is just hovering above 1. It's the lower display. Just let me see if I can refocus that while we're doing these tests. No, it's not letting me. Now that is into a 50 ohm dummy load on the test set, and what we have here is a 25 ohm dummy load, which represents an SWR of 2 to 1. So I'm going to connect the radio set into the 2 to 1 dummy load. Says he, trying to do it with one hand as usual. I must get more organised for doing videos. Now when we press the PTT now, we should see at least 2 bars. In fact, we've got 4 bars, I think. Oh yeah, it's coming up to 2. So that's showing us that we have, with a 25 ohm dummy load, we have an SWR of 2 to 1, which is correct. Now if we press the antenna tuner, that should detect 2 to 1. Auto tuners tend to aim for a 1.5 to 1 or 1.2 to 1. They're not absolutely perfect. They sort of give up tuning when it is at an acceptable level. So I'm going to press the tuner now, and then go back to the PTT, and you see we still have 2 to 1. So indeed the antenna tuner has not tuned the circuit. So in the next segment I'll explain why that is. So we've got the it's in CW mode, and we've actually gone through the menu and we've set the power output to be 100 watts, as you can see, and I'm going up to the test set now, and remember it's 1/10 on here. So pressing the PTT button, you see we have 6.2 watts, 6.2 watts, which is 60 watts and not 100. So coming back down, I'm going to set the RF power output now to 50 watts. 50 watts, so you would expect to see 5 watts in the display here on the test set. I'm pressing the button, you see we've got 0.5 watts, which is 5 watts in total, and not 50 watts. So 5 watts instead of 50 watts at the 50 watt setting. And then one more test I'm going to do is come down and select 10 watts. Now we're on 10 watts, and again going up to the power meter. I'm pressing the button now, but it's not detecting anything. So what I'm going to do is go to the spectrum analyzer to see if we can measure the level there. Let the software come up. Of course the sun's come out now, and there you can see we've got minus 15 dBm, where it should be 10 watts. So the reason that the antenna tuner isn't working is that the power amplifier isn't producing enough power. By selecting 10 watts here on the menu, we're actually putting the same amount of power in that the antenna tuner likes to use, and the antenna tuner is failing to use it. Now what I'm going to do is press the tune button here, and we're going to watch the spectrum analyzer. It'll be a very quick, brief show. I don't know if you're catching that. Yep, but it's not going above neg 15 dBm. So there's not enough power going into the antenna tuner for the detectors to detect the SWR, and that's one of the reasons that you see when I press the tune button you get full scale SWR very briefly, because there's just not enough power there for the detectors to work. So in essence the PA has a fault. It's not producing enough RF power output. Although it would probably still work on voice, the owner's probably been using it, speaking to people, but not quite getting the same range, and obviously not the same power output. So we're going to take a look at that next. Okay, so Kenwood are one of the few manufacturers that put drive levels into the service manuals, and they tell you what voltage or power level you should get at various stages, including the receiver, the IF, etc, etc. And what we're looking at here is the 100 watt PA level diagram. So here you see the two FETs that are soldered onto the main PCB board, and then the pre-drivers are the two that are on that metal strip, and then you've got the two finals, the PA, which go out to the tuner unit. So you see on top of the first FET, this is at 14 megahertz, you should get 300 millivolts peak to peak in transmit mode. The next FET you should get 3 volts peak to peak, and then into the drive of each of these you should get 4.9 volts peak to peak, which doesn't make a lot of sense, because if that's 3.1 and you've got a transformer coupling and a 50-50 split, you'd expect that to be less. But at the output of those two FETs you should have 7 volts peak to peak, which then goes forward to drive the PA. And so we're going to look at, on the oscilloscope, what levels we have there, and that may give us a clue where we're lacking in gain to get the full output from the PA. So let's do that right now. Okay, so I've been along and done the measurements. It was a bit difficult to hold the camera, do the measurements and show you the scope. So this is what we had. The input to the PA board should be 128 millivolts peak to peak. It was 220, so that's good. This stage should be 320 or 300 millivolts peak to peak. It was 320. This is 3.1 volts output. It was 2.64, so slightly lower. So you measured the input, so we're getting 134 millivolts to 2.64. So that stage has gained, therefore the FET is working. And then we come to the push-pull stage before the final PA. So here we should have 4.9 volts peak to peak, and we've got 1 volt with an output of 1.6 volts. And on this side we've got 2.8 volts drive with an output of 3 volts. So it looks like this FET has gone down. So we'll do the voltage checks to confirm that. But just to show you on the radio, this module here, in fact I'll stop the video so I can get a better focus than that. There we go, that should be a little bit better. So you've got two FETs on a sub-assembly, you can see that, on a metal plate that screws either end. Now the difficult thing about these FETs is on the bottom there's a square of metal which is the heat sink, and that has to be soldered to this metal bar. Now the amount of heat you've got to put into them to get them on and off is quite high. You certainly wouldn't get them off with it bolted into this circuit. So we have to desolder all these pins in order to lift the board off the circuit, and then heat up the individual FET using the hot air gun in an attempt to try and get it off that board. Now the downside to that is that heat guns produce massive amounts of heat. You've got to be very careful with them, and it's quite easy in the process of getting these things off to damage the PCB, which is you know, one of those things that you just can't avoid. You know, it depends how the PCB was put together in the first place. So what we're going to do is see if that sub module is available anywhere as a spare, because I think you would change both anyway, and if it's not available as a spare, then we'll have to start looking around to see if we can buy them individually. Now one of the downsides is that most people who sell surface mount components want to sell them as a reel ready to go onto a machine, and a reel typically would hold 1,000 transistors, and at sort of $8 to $10 each, they're certainly not going to buy a reel. We might only use 10 in a year. So it's a matter of finding someone who's got them who will do what they call cut reel. He'll actually cut some off a full reel in order to sell smaller quantities, and of course they charge more for doing that. So we'll investigate anyway and see where we go from here. Thanks for watching. Okay, so back with you, having had a search on the internet. The transistors, or the FETs, are not available in this hemisphere as far as I can tell. eBay Australia shows them, but they're coming from China, and one of the problems we've had with semiconductors from China is it's very difficult to tell whether they're genuine or fakes until you've actually got them and fitted them, and it's too late then. We've also emailed Kenwood to ask about the complete submodule. I found that Kenwood parts are reasonably priced, and that might be the way to go. Mauser Electronics lists the FETs. Minimum order is 5 pieces with $30 postage. So yeah, it's quite expensive. I think they're charging something like $15 each, so five at $15 plus postage. Yeah, it's getting a bit expensive for parts that you know, may only last 5 minutes. The other thing I need to do is quick corrections in the video I've just made. I kept saying that the antenna tuner tuned the antenna to resonance. That's obviously not correct. It's just a lazy habit I've got. What the antenna tuner does, is to match the impedance of the antenna to the impedance of the radio set, so that the actual power transfer is optimized. It doesn't tune the antenna to resonance. So I hope the technical amongst you will appreciate the correction there. And I'll probably have to box all this up now, put it back on the shelf along with the other 8 or 9 radios that are on the shelf waiting for parts. Certainly the post system in New Zealand doesn't seem to be working very well at the moment after COVID-19. We're just getting parcels now in July that we ordered in May, and we've got quite a lot of notifications of parcels having arrived in New Zealand which have been sat somewhere for at least 2 months. So those of you who've got radios with us for repair, do apologise, but it's beyond my control. Can't fix them without the parts. So thanks again for watching, and hopefully you'll find this video interesting, and eventually we'll get stuff put on our website. We do have some second-hand radios on the website, those of you interested in looking, and we're also the New Zealand agent for BHI noise cancelling products. You've seen the sort of thing, loudspeakers with DSP embedded, and they're very good. They seem to do exactly what it says on the tin. So, and now you can buy them in New Zealand. So once again, hope you've enjoyed it. Thanks a lot. This is Joe, ZL1PMY, signing out.